So hi, my name is Pavel. I'll talk about Kubernetes, which is a container cluster management system. I actually wanted to start by asking who uses Docker or Kubernetes, but I got the idea yesterday. There was a lot of talk in the open sessions about it. So it will be a very technical presentation, but I hope it will be interesting for most of you. And I have a lot to tell you, so don't hope for an early lunch. So a little bit about Movio, what the story with Docker is in Movio, and what path we took. So if you can find yourself in the same position, maybe you can benefit from my story. So in Movio, we do software for cinema chains, cinema exhibitors. If you have a loyalty card in your favorite cinema, there's a high chance you're probably in our database. The chance in New Zealand and Australia is about 100%. In the US, it's a little bit less. In Europe, it's even less. So whenever you receive an email from your cinema, that email is actually from us. We send about 100 million emails a month and a couple of millions of SMS and push notifications. And even though it turns out people don't like push notifications, so we don't do that anymore. And it all started about 5 or 6 years ago with a good idea in New Zealand, in Auckland, and with a MySQL database and PHP application. As you can hear, we have a lot of customers now, so the data influx during the first years was huge. And about 2 years ago, we ended up, luckily, everything's hosted on Amazon's AWS from the beginning. So do you know how MySQL and PHP scales? It doesn't. So 2 years ago, we ended up on the biggest instance you can get in Amazon, and it was still slow. The biggest in the i2 type, if you know Amazon. It's still like 64 CPUs and 120 gigs of RAM, but it was slow. So at that time, we chose, or that was the time I joined Movio actually, and the decision was to go with microservices to pull down the big monolithic application into small pieces. And the choice was Docker to start all the new services, new features, new microservices in containers. And so I was there throughout the change to containerize everything. And we chose the tools which were available at that time to deploy containers, which was Jenkins, Puppet, and our own Docker registry, and push it to Amazon's EC2 instances. I wrote this blog about a year ago, and I was really happy about it. We deployed, with Puppet, Jenkins, and stuff, and everything worked. And don't get me wrong, it's a good solution. It was probably the best at that time. It works. It just turned out the devs were not so happy about it. Whenever you want to deploy a new microservice, you have to write some Puppet code. You have to take care which server you deploy to. You have to take care of port conflicts. If you want to scale horizontally, you have to find new servers. You have to put your own load balancer in front of those servers. So we started to look into some new container management tools early this year. And so we run this squad teams, the Spotify thingy. We have I don't know, 6 teams, small teams of devs, and they actually pushed for a new way of deploying the containers. And I'm on the ops side, even though I'm inside the teams. So I kind of think we run a DevOps culture because I'm ops, but I'm part of the dev teams. And I was pushing for this tool called Nomad. Maybe anyone heard of it? It's a HashiCorp tool, which does basically the same as Kubernetes. But the devs were so heavily involved already that they were trying Kubernetes and they overruled me to choose Kubernetes. So I took it as my own tool. We deployed it together, and now we use it for more than half a year in production. And this is what it gives us. So we don't have to worry about ports. We have built-in load balancing. It's HA. If a node goes down, your microservices will be shifted to another server, hopefully with no downtime. And you get health checks, you get other stuff. You can find that on the website of Kubernetes. There are a few concepts in Kubernetes while I'll be doing the live demo, so I'll be talking about pods, so you better understand that. So a pod is basically a container. It can be more containers for the purpose of this presentation. Imagine a pod is one container. Then you have this notion of deployments, deployment sets, pet sets, which is a way in Kubernetes how you unify your containers in an application which has more layers, for example. A service is just a resolvable name in Kubernetes which does the load balancing for you. So if one service talks to another, in Kubernetes it calls the name of the service, and the service, the notion in Kubernetes, will load balance the traffic to all the pods which belong to this service. Config map, volumes, all the things you know from Docker are possible in Kubernetes as well. So let's go to a live example. So I have a dev cluster here. There are 8 nodes. It's used in Auckland by all our devs, so probably used now. You see some CPU memory going up and down there. And I will try to deploy an easy Nginx container, which will just show a status page. And then a service. Then I will make it public for you, so you can try that out. Then I will try to scale it up and down with no downtime. So let's do it.
Just thinking about the demo going forward.
Yeah, the presenter's curse. So this is how you deploy an easy Nginx container. And I don't do this every day for all the dev guys. They actually do it themselves. So we had this talk by Owen yesterday here that devs don't know anymore how things are deployed. So I think this brings back the culture of devs actually running their own deployments. So can you see that? Make it a little bit bigger. So this is my Nginx demo 100, and some names and stuff. All you have to care about is your image and the part you want to expose from that container. And I have this kube control tool, which is a binary you run on your laptop to connect to the cluster to deploy your things or get information about your cluster. So I will show you that I'm doing this live, that there is no pod running now. Yep, doesn't show me anything. So if I do create the Nginx deployment, it will tell the cluster to pull this container, run it on any node which has resources for it, and it will do it for me. Oh, it's already running. And that's how easy it is. But now it's running in a Kubernetes which uses its own networking, so I can't reach it from here now. That's why I'll deploy this notion of service, which makes the load balancing I was talking about for you, but it also makes it easy to expose services running in the cluster to the outside world. So in Kubernetes, there's a thing called labels. So if you notice before, I deployed the Nginx with a label name equals Nginx pod. So this service will encapsulate all pods running with this label. It will expose a port on port 80, and it will route the traffic to the Nginx container too. Actually, if I scale it up, it will load balance the traffic to all the Nginx containers. So again, I just tell the cluster to deploy this service. Create it. So if I go to now the service creates an endpoint on the Kubernetes API server. It exposes your services to the outside world. So I deployed a service in my namespace called demo, and the service is Nginx service. So as you can see, it worked. This is the Nginx basic status page. So I can hit my microservice if you want from here. Okay, now if you build a container, if you know containers, you build the app inside. You don't want to build the configuration inside because you want to deploy the container to tests, UAT, production with different config. So Kubernetes allows you to mount in the configuration you want, and it's called config maps. So I will override the basic Nginx configuration inside my container with this server example, which will just tell my container to serve a file from this directory, where I've prepared a file which will show us the internal IP of the container. I will use that later when we scale up. If I reload the page, I will see different IPs. So it will mean that it's working fine, load balancing between all the containers. So let's deploy this config. So this just creates a file with my configuration in Kubernetes. Now I have to tell my Nginx container to actually mount this configuration file inside a container. I do that by specifying this. Yeah, you can see that I say take this Nginx config server.conf file and put it inside a container on etc Nginx conf.d. So I've already deployed my container without this configuration. How do I now do an update in the living thing? So I've made change to the YAML file, to the deployment config, and this is how easy it is to actually reload, redeploy your application with new configuration. So I will apply the changes in the cluster. Once that's done, I'll load the information of my running containers. And you see it's running 13 seconds, so it has already redeployed my container with the configuration file mounted inside. So this should now change to, this is the file I've put on inside the container. It shows us the name of the container it's running in and the internal Kubernetes IP for this one container and a version 1.0. So that's how you mount configuration in your containers. If you want to have configuration separated from containers in test, dev, prod. Now I'll make the service publicly available for you. So this is again the config I used before for the service. Now if I specify type load balancer here, Kubernetes have great integrations with many of the well-known cloud providers, AWS, Azure, and many others. So this will actually do stuff in AWS for me. You can't do a in-place update of a service, so I'll have to delete the previous one. Nginx service. And I'll recreate the new one with the type load balancer. Cool. So if we have a look in AWS, I hope the resolution allows us to see at least something. So the integration with yeah. So if the resolution was better, you would be able to see there's a new load balancer created just now, 30th of September, which includes, can you see it? Yeah, it includes all the instances in the cluster. It routes the traffic inside the cluster and it hits my container in the end. I will make this. This is a public DNS you get from AWS. So I'll make a nice URL for you so you can actually try it. Let's say I'll create demo.moviodev.co. Take your phones and open a web browser. Yes. And if you go to demo.moviodev.co, try that now. Yep. We have to probably wait for the DNS to propagate. Oh, yeah. Can't see anything here. Yep. Oh, come on. Yep, that would work. If it was yesterday evening at home.
For me, always reopening browser works. I don't know why in this case.
Yeah.
Rebooting the machine, right?
One more thing to check. Let's check if the service doesn't complain about anything. So the service I deployed is here. You can see, oh, you can't. So I'll show you again. The service will show you the DNS of the load balancer, and if you do describe service and the name, you should see if there are any issues with your service.
It does work now.
It's working?
Yep.
I was going to take a photo.
Cool. So yeah, try that on your own, because I want to see some traffic on this side while I will be scaling it up and down, and then I'll do a rolling update with a new version. So if you are reloading during my presentation, you should see all the changes on your own. And also, we have a centralized logging there, so I will get all your Android versions or your IPs and stuff like that. Okay, so I have a service publicly available. There are many other ways how you can expose a service from the cluster. You don't have to have an AWS load balancer for every one of your microservices. That might become costly. You can bypass that by exposing ports on the real servers you have, and then put just one load balancer in front of the whole cluster. That's how we do it, but there's not enough time to talk about all of that. Yeah, not much time left, so
I've got an extra 5 minutes.
cool, great. Give them public URL. I've just done that. Make it scale with the deployment. So if you have noticed in the deployment file, there is this line with replicas 1. So if I make it replicas 5, that's all I need to do to make my microservice HA and multi whatever. And all I need to do is apply the new config to the cluster. And after the internet comes back, I will show you how many containers are running there now. Okay, they're already all running. This one is the old one, which I deployed 10 minutes ago, and there's 4 new ones running 7 seconds. So if you go back to your browser and reload many times, you should see that you're hitting different IPs. If you're not using Chrome, which caches aggressively. I actually found out Firefox to be much better for this. Or worse, if you want to use cache. Def. Yeah. Okay, Firefox doesn't work. I probably cached my testing from yesterday. Okay, can anyone try to reload the page and see that the IPs changes, that you are hitting all of the 5 containers? Awesome. So that works. Now, rolling updates. You your devs come with new app, you want to update without any downtime. So that's easy as well in Kubernetes. This line with the image tag, there is a new tag. If you have a look here, it's a breaking change. It needs a new major version. It will change this line. So I'll make it tag 2.0. And again, I'll apply the new file. If I have a look, you should see the old containers will be slowly terminated and the new ones will start up. And it also, you can configure how many minimal numbers of containers needs to be running at a certain point of time. So you can say kill one old first, then start one new one, or you can say start all the new ones first and then slowly kill the old ones. I think by default it goes one by one. So now all the new ones are started, all the old ones have been killed. So it was pretty fast, so you wouldn't be able probably to reload during the rolling update, but if you were, you would be hitting once version 1, once version 2, and slowly you would be only hitting the new version. And that's what you want. So there's a few best practices. It's a new technology, so not everything will work out of the box in the cluster. And this is what we have learned during the last 6 months. We use Kubernetes. So make your containers small, because if a node goes down, then you might be running 20 containers on that node. They all need to be shifted to different nodes. So it will start pulling all your containers at the same time. If they are huge, it will take some time. And it will make, if you are not running multiple instances of your containers, it will make your downtime higher. You can, if you log on containers standard out in JSON and you use Kubernetes plugin for the centralized logging, you will get all your logs in Elasticsearch and Kibana. You can search for all the messages you want. Test and know your resource requirements. That's quite a big one, and I also wanted to put this presentation in the DevOps theme of this conference, and that is how close you need to work with ops and devs. So as I said before, we run the Spotify squads in Movio, and I'm actually on the ops side, but I'm part of the dev teams. I'm shared among 3 teams, and I don't deploy for them. They deploy on their own. They build their images, so they know the best what the resource requirements are. In Kubernetes, you can specify how much CPU you want for your microservice, how much memory you want. So if your application is slow, I don't go there. The devs go there and they have a look in the monitoring. Am I hitting the CPU limits? I'll adjust them. So it brings together, as I said yesterday, Owen was saying devs don't know how they deploy anymore, but with this tool, they actually do know. And we are thinking about making it even better for the devs, that they would own the whole cluster. They would set up their own clusters per squad. So even if something breaks with the cluster, they would be able to fix it, which is an idea, and maybe in a few months we will do that. In Kubernetes, you can mount volumes. It can create EBS volumes for you. If I show you deploying Elasticsearch in Kubernetes, I have these files prepared here. I'll deploy a Elasticsearch service. It's not interesting. It's the same service as it was for the Nginx. What is interesting is this Elasticsearch pet set, which is a notion, a new thing in Kubernetes where you specify your Elasticsearch container. But what's interesting at the end, if you can see it, is you tell Kubernetes provision me disks. I will slide. Provision me 10 gigs of disks for each of my Elasticsearch node. And through the AWS integration, it will do it for me. So if I do create Elasticsearch pet set, it will slowly start 3 nodes of Elasticsearch inside the cluster. It will also volumes. You see there are 10 gigs big new disks created just now. So that's what Kubernetes provisioned disks for me. It mounts them in the cluster to the correct node where your Elasticsearch container is running, and it will mount the data in the container. So if your node or your Elasticsearch node dies, it gets rescheduled to an alive node in the cluster. This volume will actually travel with your container. Kubernetes are aware of the availability zones, so it will only schedule your Elasticsearch node in the same availability zone as your disk is. And you will see as it slowly comes up, it will mount one, then the second one, then the third one. I can show you how it's starting them up. Yeah, so that was one of the best practices. Deploy stateless applications, but if you have to, you can deploy applications as with volumes, as Elasticsearch, Cassandra. We even tried Kafka in Kubernetes. You can, but you have to make sure those applications will survive immediate restarts, because it can happen in such an environment. Okay, that's end of the best practices. We can go back and see. Yeah, that is still starting the first Elasticsearch node. It will take a while. So I think that we have run out of time. So if there are any questions.
Are you a convert? You said this wasn't your first choice and it got forced on you. So are you a convert to using this?
No. At the early this year, I was playing with the Nomad, the other tool, and from my point of view, ops, it was really easy to set up. But it didn't have as many features as Kubernetes had at that time. I don't know if it has now. But since I'm part of my teams, I'm not just ops alone. We have a democracy, right? So we voted, and the vote was for Kubernetes. So, yeah.
Can you comment on any particular workloads that don't work well in Kubernetes? So is there anything that you're running that doesn't favour it nicely, doesn't survive those restarts?
Yes, so Kafka. So as I said, you have to handle restarts well. and Kafka uses Zookeeper for its leader election and config saves. And if you kill Zookeeper, even though it's clustered system, it loses one node, it goes down. You have to wait like 30 seconds for a safe shutdown, but that you can't force a node when you have an outage to wait 30 seconds before it goes away. So that didn't work. But if I namespaces, this might be confidential because I will show you all the containers which are running in this dev cluster from other teams. How do I make it smaller? Anyway, there is SMTP servers, there is Prometheus, there is Cassandra running, there is Elasticsearch running. Those all play very well. Oh, and one more thing, in the best practices, if you have a look on the slides, you have to be aware what's your instance sizes in the Kubernetes cluster, the servers, how big they are. If there's a team, they want to deploy their application, enterprise application, with 5 gigs of RAM, and there is not a node which can handle that, you can't do that. So you have to be aware of the resource requirements.
What version of Kubernetes are you running, and how do you upgrade a cluster?
We are now on 1.3.7, which was released 3 weeks ago maybe. There is 1.4 now, released last week. We haven't upgraded yet. So when it's a minor change, when you don't have to upgrade OS or Docker or whatever other tools you use, we allow SSH from our Rundeck server. If you know, Rundeck is a great tool for running bash scripts on your servers. So we tell Rundeck, download these 2 new binaries on all of the Kubernetes servers and restart the binaries. We run kubelet and kubeproxy, which are 2 binaries you need on the worker nodes to run your whole Kubernetes cluster. So we just download the new binaries and restart it on the fly, and it works. It doesn't cause any issues.
All at the same time, or one by one?
One by one, yeah. If there's a major change, we have built an AMI in AWS, an image. So you have to upgrade the master nodes first, the API. So we add new nodes with the new version, and then we deprecate the old ones slowly. That causes a little bit, some issues because we have, for example, in production, I think we have a cluster of both US and Europe might have 20 nodes together with I think it's like 300 applications running in them, or containers, 300 containers. That gives you 15, 16 containers per node. So if you are deprecating the old nodes, all these needs to be shifted to the new nodes. So you better run it in multiple instances. If you don't, then you get a downtime. But that's how we do it. AWS AMIs. Yeah, I can show you in the dev cluster. It has 8 nodes, and it's running some. I would say 100. Yeah, 120 containers on 8 nodes. So another good feature or benefit of Kubernetes is the resource utilization. This is test. If we needed to deploy 120 containers on separate servers, they would be probably sitting there doing nothing most of the time when no one's using them. So this is how you can share the hardware, get more money for less.
Is there a way to measure the performance of your clusters?
You mean monitor? Yes. So Kubernetes has this notion of add-ons, and they are all exchangeable. So they provide you with a default monitoring tools, which uses Hipster to collect all the stats from your nodes and push it to Grafana. But if you want, you can change it for something else. For example, some of our teams run Prometheus inside the cluster and monitor resource utilization by Prometheus. This is the default add-on for monitoring your resource utilization. So if I go to my demo namespace and have a look in Nginx deployment. So this is the thing I deployed a few minutes ago, and I didn't need to set up any monitoring logging. It's auto-discovered. And you can see here, yeah, if the resolution would allow, you would be able to see how much CPU my Nginx is using, how much memory it's using, how much network traffic there is, how much file system it's using. So yes, there are good ways of monitoring. And for example, Prometheus already has a plugin for Kubernetes that it auto-discovers all your new containers in the cluster.
What's the sort of multi-tenanting like in Kubernetes? So say you have multiple tiers, so you have a web tier and you have a sort of back-end app tier, and you want to put a logical separation between those so they can't necessarily talk to each other. Is that easy to do in Kubernetes, or?
Yes, I would say you would deploy every tier as a different service. So I deployed the Nginx service, that would be your web tier. Then you would deploy a Java service, whatever. And so Kubernetes has its own built-in DNS. So your web tier would call your backend service by a name. It doesn't give you any like firewall or anything. So any other service of your teammates can actually talk to your backend service as well. So it's not very secure, but it's your team running the Kubernetes, right? So you trust each other. So yeah, you can separate it by services.
So there's nothing like sort of Docker networks where you can have a separate network and they can't broadcast across or anything like that?
So the networking is developing very fast in Kubernetes. There are a lot of, so as with everything, you can exchange it in Kubernetes. We are using Flannel as overlay network. You can use other networking services. There is this project called Romana. They're working on layer 3 networking, and I think they allow you to put security like firewalls between your services. We don't do that. But you can probably.
Excellent. Thank you very much, Pavel.